All right, everybody. Glad to be back to show you another example. And this one I find right from the assignment, and I think it's straightforward in the sense that I don't have to read between the lines here. It's not like it's a word problem where I have to sort through the information. All it says is that I have this function and I want the derivative. Okay, so let's talk about that. If this is the function I'm given and I'm trying to find the derivative, first thing to think about is what rules are applicable. Okay, and on that note, I'd like to ask you if you see that we would need two different rules used in sequence. Okay, first the chain rule, because this is a composite function. There's one function inside of another one. In a sense, one of the operations is the 1/4 power, raising to the 1/4 power. That's a function all by itself. But inside of that, if you think about order of operations, there's something else that has to be done first. That is a fraction, a quotient, a rational function, and we would have to use the quotient rule for that. Okay, so there's two rules that are applicable, the chain rule and the quotient rule. As far as how we would use the chain rule, I'm looking at this like, let's say u is the function inside that 1/4 power. All right, u is a function of x. It's 4x over 5x minus 3. The derivative using the chain rule of u to the 1/4 power is, well, I'd bring that power to the front as a coefficient. I would subtract 1. 1/4 minus 1 is negative 3/4. Then to complete the chain rule, I would multiply that times whatever the derivative of u is with respect to x. Meaning, whatever the derivative of that inside function is what would go here. What the derivative of that inside function is, well, how would you find that? That part. What's the derivative of 4x over 5x minus 3? Well, you use the quotient rule for that. So we'd have to complete things sequentially like that. Okay, let's do this. Of course, you don't have to do it the way I do it, but I thought, why don't we do this in two steps? Okay. So first, let's find the derivative of that inside part, because I know I'm going to need that. And I'll just like find that all by itself. So what's the derivative of 4x over 5x minus 3? Well, that's by the quotient rule. That's derivative at the top is 4 times the bottom, 5x minus 3, minus the derivative of the bottom is 5 times the top, 4x over the bottom part squared. I do a little algebra and I work it down to negative 12 over 5x minus 3 squared. Okay, that's the quotient rule. That's this du dx right there. What's going to go right there is negative 12 over 5x minus 3 squared. Okay. What about the chain rule, like completing that? All right, this. I think we have everything we need. Okay. It's like, okay, bring the power to the front. All right. That's the u. That's the interior function there. 4x over 5x minus 3. Subtract 1 from the exponent, negative 3/4. And then I said, like, that du over dx, the derivative of the inside function, however you want to say it. There's lots of ways to describe the chain rule. It's going to be that, right? Okay, it like unfolds that way. So then that part, I found that already. That's why I broke this into steps. I just thought it might be easier to follow that way. That's negative 12 over 5x minus 3 squared. Okay, so the question was, can you find y prime or dy dx? Either way you say it, can you find the derivative? And I'd say, okay, we found the derivative. I used the rules correctly, and I got something, all right? So I'd say, okay, we found the derivative, or did we? That doesn't look, I mean, it looks kind of like that answer, but it doesn't look exactly like it. So what's the deal there? Often, like when we learn calculus, when we learn how to use the rules, we'll use the rules in a few steps, and then we might spend several more steps simplifying our function, canceling unnecessary numbers, combining things, and so on. So two mistakes here on my part. I said we do this in two steps, and I said, well, okay, I guess we do have to simplify it. So there's a third step being algebra. I don't know why I wrote step 4 there, but you'll have to overlook that, okay? So yeah, either way, there's this additional step of algebra. So let's think about this. I took this, I copied it down over there, and I want to think about how we can take this and simplify it into that, all right? So there's a few things that we'll do. First, I'll say, well, how do exponents apply to a fraction? Like if I have this entire fraction with an exponent applied to it. You could think, if you wanted to, if it served your purposes, you could say, well, this exponent gets applied individually to the numerator and denominator. So that's what I wrote here. Okay. So now I've kind of laid it all out. I got a 1 on top of a 4 times 4x power negative 3/4 on top of 5x power negative 3/4 times negative 12 on top, 5x minus 3 in the squared on the bottom. Now see what can be combined here. First of all, negative 12 divided by 4, negative 3. 4x to the negative 3/4. I can't do anything to make that simpler than it already is. So, I mean, I could do this. I could take it and put it under the bar, and its exponent will become positive. I could do that, all right? And then the last thing is, what do you think about this? Like, say you have 5x minus 3 power negative 3/4 times 5x minus 3 power 2. Can those be combined? I mean, when I multiply fractions, I multiply straight across. So these two things do get multiplied. If you were going to multiply these three fractions, part of that would be 5x minus 3 power negative 3/4 times 5x minus 3 squared. But can those be combined? That's my question. So the rules of exponents do allow that when we multiply like bases, we add the exponents. It's just as long as the bases have to be the same, you can do that. And they are here. The base, the thing that's getting raised to the power in each part, is 5x minus 3. So I wrote it here like a rule. It says a to one power times a to another is a. You add the powers together. So I can do that here. That's applicable here. Even though this situation looks more complicated, the bases match. What I'm going to get, multiplying these together, is 5x minus 3 power negative 3/4 plus 2, whatever that is. That's 5/4. And there I have it. Now it's simplified. I'm looking at that. Maybe the algebra is the hardest step. Who knows? But I hope one thing that you learn is that when you do calculus, you learn calculus. You learn the rules. You learn the applications. I mean, hopefully you learn all that. There's a lot to learn when you learn calculus. But you might also find that you're learning a lot of algebra, maybe better than you thought you knew it. And maybe you're having to really think and review about some things that you thought you knew already. Here might be an example of some of that stuff.